Good morning.
Good morning.
So it's my pleasure to welcome you here to Stennis Space Center. My name is Joe Schuyler. I'm the Engineering and Test Directorate Director. I'll be talking a little bit about Stennis history, what our role is in the Artemis program, as well as some of the other activities we're involved in here at Stennis. And I know we're running a little bit behind, and I'll try to speed it up so that you guys can get to the real fun stuff today. So tours are always great. Hopefully it'll clear up out there so you can get some good views out of the test stand.
Excuse me. Sorry, may I put my mic so I can get your audio?
Sure. So, a little bit of high level about the NASA vision and mission. This is kind of the cornerstone of where we derive our own vision and mission and what we do here every day at Stennis Space Center. So the vision is for NASA to discover and expand knowledge for the benefit of humanity. I won't read through the whole mission. However, there are 4 goals that ride along and support that vision and mission. And Stennis Space Center is involved and engaged in 3 of those 4, the 3 in red. So goal 2 is extending human presence deeper into space and to the moon for sustainable long-term exploration and utilization. Goal 3 is addressing national challenges and catalyzing economic growth. And goal 4 is optimizing capabilities and operations. So, like I said, we derive our vision and mission from NASA's higher level vision and mission. And we developed a little word cloud associated with that on the left-hand side, and obviously the thing that pokes out the most is propulsion testing. That's our primary line of business and what we focus on here at Stennis Space Center. But our vision is SSC leads propulsion testing and enables partner mission success. Stennis Space Center is the partner of choice for providing propulsion test capabilities to the nation. We utilize its unique location and assets to collaborate with other agencies, academia, industry, to develop and test autonomous systems, enhance national security, and increase knowledge of the Earth and its oceans. Our strategic goals that support that, the first one, by 2025, Stennis Space Center will be home to a modern, sustainable propulsion test enterprise, providing world-class test services to NASA, other government agencies, and commercial customers, as well as fostering an entrepreneur-friendly environment where commercial providers design, manufacture, assemble, and test space launch hardware. We've been supporting the commercial enterprises for a long time, and more recently we've moved out on supporting one company, Relativity Space, a good deal here. They have a couple of test locations, as well as we just established a host tenant agreement with them for a facility for them to begin manufacturing in the 9101 area. Goal 2 is SSC will continue to provide an environment that enables efficient, effective support of NASA and tenant missions while providing for growth opportunities for development, tests, and operations of unmanned autonomous systems by NASA, other government agencies, and industry. With that, I have an overview video. If you could start that for me, please. B2 in a little while, but some of that early footage was of the Saturn V testing up there in the 60s. So a little bit more about Stennis's history. Before I go, some of the imagery in there also talk about autonomous systems, and I won't get into it too much more in the package, but just to make a note, that's one of the areas that we're working on developing more and more of that capability here at Stennis Space Center, and it's going to be imperative towards deep space exploration in the future. The further away you get from the planet, the more you need assistance from your systems on board in order to control and maintain whether it's a mini space station or a HAB module out in deep space because of the time difference in communications between Earth and that module. So we're looking forward to more work in that area. Stennis Space Center was established in the 60s to test the engines that propelled the Apollo spacecraft to the moon. This site in Hancock County was selected because it provided an isolated test site with an acoustical buffer zone, water and road transportation capabilities, a supportive community, and a climate conducive for year-round testing. In 1963, the first tree was cut for test site construction, and about 3 years later, the first Saturn V test was conducted. In '71, Space Shuttle main engine test role was assigned to Stennis, and we not only worked on the development of the engine, but also green run and checkout tests for every Space Shuttle main engine that's flown. In 1988, the site was renamed to John C. Stennis Space Center, and in January of 2015, the first RS-25 engine test was conducted for a Space Launch System. And today we are still America's largest rocket test engine facility. And this is a quote we like to repeat over and over, but Dr. Werner von Braun said, "I don't know yet what method we will use to get to the moon, but I do know that we'll have to go through Mississippi to get there." And that still holds true today. And aside from a rocket test facility, like I mentioned earlier, we're a federal city. This is a list of all the federal and state agencies and commercial companies that exist here at Stennis Space Center. There are over 44 of them. It's a vibrant community that supports the mission and goals that we discussed earlier. And so there's a lot going on here at Stennis other than just rocket testing. This is a snapshot of our economic impact from 2018. On the left, you'll see the global impact of approximately $875 million. You can see the breakout of what contributes to that. NASA makes up about $247 million of that. The direct economic impact within the 50-mile radius is significant as well, with a similar breakout. And on the lower left, you can see the total workforce is approximately 5,200 on the site. The average salary with benefits is about $90,000. And one of the big drivers in that, when you look at the education levels in an employee skills summary, about 80% have either technical skills, craft skills, business professional skills, or science or engineering backgrounds. And as well as in the education levels, about 77% have some college or higher. So that's what drives those wages and so much higher. On the right-hand side, the residential distribution of Stennis personnel, the breakout is pretty simple. It's about a third to the west in Louisiana, about a third north in Mississippi, and another third east in Mississippi. So we're kind of surrounded. We're so separated, but people have positioned themselves pretty evenly in those surrounding communities. And again, we've got a proud propulsion test heritage here, starting in the 60s. These are the three biggest things to come through here as far as large programs and testing for Stennis Space Center. Obviously, the Apollo missions and Saturn V stages, first stage and second stage testing, And then for Space Shuttle, like I mentioned before, development of the Space Shuttle main engines, as well as the main propulsion test article test that was done out at D2. And then all of the testing that we did for every single engine. And now the next big program coming through is Artemis. And again, we're testing the RS-25 engines here to support that activity. I know over the last day you guys have done a lot with Artemis, so I'm not going to breeze through this. And go to the next slide. This is really what we're doing here at Stennis to support Artemis. So our role is testing the RS-25 engine on the A1 test stand. This test was conducted in January 2015. And then also the B2 refurbishment and build out to support SLS core stage testing. A little bit more detail about RS-25. There are 4 engines that will power the core stage of the world's most powerful rocket, the NASA Space Launch System. It towers more than 200 feet tall, diameter of 27.6 feet. It'll store cryogenic liquid hydrogen and liquid oxygen that will feed all 4 of the engines. We began testing the engines in January 2015 at the A1 test stand, and the last engine test in April of 2019 completed the following. We had completed out acceptance testing of the 16 former Space Shuttle main engines that will help launch the first 4 SLS missions. NASA has contracted with Aerojet Rocketdyne to build the new RS-25 engines for additional SLS missions, and that work is underway. Development and flight-worthy testing for the new controllers to be used by the RS-25 engines for the first 4 missions. This 51-month test series demonstrated that the engines can perform at the higher power level needed to launch the Super Heavy Lift rocket, and that equated to 32 developmental and flight engine tests for a total of 14,754 seconds. And that's more than 4 hours of cumulative hot fire, and that was all done on the A1 test stand. B2 test stand. This is where they'll bring the core stage for the SLS. It'll consist of firing off all 4 of the RS-25 rocket engines, just as during an actual launch. Since the B2 test stand was originally built in the 60s to test the Apollo program, major modifications were required for the Artemis program, and some of those include upgrades or refurbishment of every major system on the stand, replacement of the 50-year-old high-pressure industrial water line and system to provide service to the A and B test complex during testing, repositioning and extending the B2 test stand main propulsion test article framework by adding 1 million pounds of structural steel and about 100 feet of height. And you'll see a little bit of a video of the repositioning piece coming up soon. Installation of an additional pump and piping needed for support of acoustic suppression testing during testing. You could run that, please.
NASA is building its new Space Launch System vehicle, SLS, to carry astronauts into the next great era of deep space exploration. Before SLS launches, however, it has to be tested. Operators will install the SLS core stage on the B2 test stand at Stennis Space Center, Mississippi. They will fire its 4 RS-25 engines just as during an actual launch, generating 2 million pounds of combined thrust. Preparing the B2 stand for the test has been a daunting challenge. Upgrades of every major area of stand operations, modifications to electrical, data, mechanical, and propellant piping systems, strengthening of the B2 derrick crane to lift the core stage onto the stand, repositioning of a 1.2 million pound structural framework that will house the stage, addition of 1 million pounds of steel to strengthen and extend the stage framework, replacement of the industrial water system to increase flow capacity to 335,000 gallons per minute. Delivery and installation of special test equipment. Readiness tests of all necessary capabilities. Multiple NASA and contractor project teams. 6 non-stop years of hard work. Milestone mark after milestone mark. To clear all hurdles at last and announce Stennis and the B2 test stand are ready.
A couple of things I really enjoy about that video when you see the large valve and the little people standing right next to it. It's just kind of daunting how huge some of this stuff is. So this is an overview of the test complex in general. You can see up here the B complex, and you'll be going out to B2 to see where they've been doing the activation and preparing for the core stage. On the B1 side, on the other side of this test stand, is where they test for RS-68. Aerojet Rocketdyne actually runs that test stand and that testing that goes on there. And in FY19, they did 6 tests for over 1,000 seconds of test time. We've been in a commercial agreement with Aerojet Rocketdyne for over 20 years in performing the testing on that stand. And Dr. Gilbert likes to say we were working with commercial companies before it was cool. A2 right now is not occupied. A1 is where the RS-25 is, and will be going back into testing in the spring of next year. And then A3 is not occupied. And out at E complex, we have our smaller test stands, but we tested with AR, Stratolaunch, and Relativity Space out there. So 7 of the 9 test stands are active. E2 and E4 right now are under a Commercial Space Launch Act agreement with RSI, and only 2 of them are not occupied, A2 and A3, and that's going to be that will be available through an AFP to promote commercial propulsion testing. And to just talk about a little bit between stages and engines. Our test stands simulate things, right? So like a core stage, when we put the core stage out at B2, the test stand will simulate being the launch facility. When we test an engine, the test stand actually simulates being the vehicle. And when we test a component, or a subcomponent in E complex, the test facility acts like it's another part of the engine. So as we go through this, we gain more confidence in components that integrate into an engine, gain more confidence in the engine, then it gets integrated into a vehicle, and then we have a lot more confidence in our capability to launch and fly and be successful. This is just some of our recent commercial propulsion testing. I'd mentioned Relativity Space and their activity out at the E3 test complex. And like I said before, they're also building up and starting to do some activity out at E2 and E4. This is AR-1 pre-burner that we tested recently for Aerojet Rocketdyne. And again, the RS-68 activity that we've been doing, or they've been doing out at B1. And just give you a little bit of information about Enterprise Park. This is a development activity that we're doing to try to spur on an industrial park site here at Stennis. We work with Mississippi Power to develop this project-ready zone. We broke it out into 2 parts, 1 part outside the fence line and 1 part inside the fence line. And the intent is to have a space where a third party can manage an industrial park for Stennis and bring in folks that want to support either our mission or our tenants' missions, and it can be either within the security of our site or outside, but still within the fee area of Stennis Space Center. So it's still in development. After some of our research is done, there'll be a notice of availability, a request for proposal to gauge industry interest. And then depending on how that goes, there's opportunities to expand this in the future. And also also we have restricted airspace, which is fairly new over the last few years for us that we've been managing. We've always had restricted airspace over the test site, but it was much smaller. We worked with the FAA to develop a larger, all-encompassing our 4403A site, so that when we test, we can ensure that we're being safe and we're not impacting any flying in the area. But also, we can do test flights in the B area with small UASs. We also have CD and E space to support military operations and training in the area over the same general region. And I don't have anything else. I know we're running a little behind, and I know you guys will hop on your buses and go out to the test stands. There are folks out at the B stand that'll meet you guys there, also at 9101. And I'm sure you guys have a bunch of questions for them about some of the intricacies of what's going on out at both of those areas. So I really hope you enjoy your time here, and it's been a pleasure talking with you.